Let's work through another proof by induction example. Here we have the sum of r times the quantity 3r minus 1 equals n squared times the quantity n plus 1, where n is greater than or equal to 1 and n is in the natural number set. So what we have to do is prove our base case. So let's see if this works for the number 1. We're going to try the left side and the right side. For the left side, we're going to have 1 times 3 times 1 minus 1, and we're trying to see if that equals 1 squared times 1 plus 1. So we're going to have 1 times 2, and we're trying to see if that equals 1 times 2, and it does. So our base case is proven. Now we're going to replace all the variables with k. Now we have to add on the k plus 1 version to our summation. So we're going to have our last term of the sequence, then our last term after that, the k plus 1 term. We're just basically going to replace these k's with k plus 1. And then we're going to do the same thing. We're going to replace these k's with k plus 1 on the right side. Now, since we have this that is equal to this, we're going to replace it. So this whole thing is now going to become k squared times k plus 1. Then we're just going to simplify and combine like terms here. We're going to distribute this. So we're going to have 3k. 3 times 1 is 3, minus 1 is 2. Then we're going to keep this right side the same, and we're just going to combine like terms. Now, if we look at the left side of our equation, we're going to have k plus 1 that is the same from both sets. And what we're going to get when we do that is going to be k plus 1, and we're going to have k squared plus 3k plus 2. And that's going to be equal to k plus 1 squared times k plus 2. Now, if we factor this, this is going to be k plus 1, and we're going to have k plus 1 and k plus 2. So you can see that the left side equals the right side, and we have just proven this by induction. Let's walk through another example. So here we have the sum of 1 over r times r plus 1 equals n over n plus 1. First, we have to prove our base case. So let's try to replace our variables with 1 and see if we get the same thing on both the left and the right side. So here we're going to get 1/2 on the left side and 1/2 on the right side. So our base case is proven. Now we're going to replace the variables with k on both sides. So we have the sum of 1 over k times k plus 1 equals k over k plus 1. Now we're going to add on the k plus 1 term to our summation. By replacing k with k plus 1. And we're going to do the same thing on the right side of the equation. Now we can simplify, and you can see here that since this summation is equal to this right here, k over k plus 1, we're just going to replace k over k plus 1 for the summation. So this is going to become this. Now we have plus 1 over k plus 1 times k plus 2. And we're trying to prove that that's equal to k plus 1 over k plus 2. This is a rational expression, so in order to solve this, we have to get a common denominator over here. That means that we're going to multiply this left fraction by k plus 2 over k plus 2, and then we're going to distribute that to the numerator. So this is going to become k squared plus 2k plus 1 over our entire denominator, k plus 1 and k plus 2. Now we're going to factor this. Numerator is going to factor to k plus 1 times k plus 1 over k plus 1 and k plus 2. Because we have a shared factor in the numerator and the denominator, they're both going to cancel. So now we have proven k plus 1 over k plus 2 equals k plus 1 over k plus 2.